Hey guys, how are you doing? It's Simon from Bizlearn again. Hi and welcome to a new episode of my tutorial series NX Freeform Secrets. As you can see, obviously I have finished the Magic Mouse. I'm not 100% satisfied, but as this is the lower area of the mouse, I think it don't have to be too perfect. If I hide my edges, you can see it seems to be tangent, curvature consistent, etc, etc. But still, the big question here was, how can I check my curvature, bumpiness, smoothness, however? And it was really hard to do by use of the reflection analysis, so I've decided to use slope analysis instead, which you might not have seen before. This gives me an information of all the slopes within my surface and a possibility to control the smoothness, and well, I am satisfied with this, but I'm still not 100% perfect. You can see this triangular shape, which is really hard to do because, as you can see, there are a lot of poles within this area. It's always hard to do triangular freeforms. Has still some knots, so it's not one segment, and the problem is not within my through curve mesh or the splines that I've used. Therefore, the problem really is my law extension, because I have not thought about the curvature, continuity, and the number of segments within here. If I show knots here, you can see there are some knots within the surface, and I really should have thought about modifying this surface by use of advanced curve fit, however, or some other kind of method to get it perfect, because all the problems we have within here, which of course is the lower surface of the mouse, it's not a real problem, will be inherited to all the following operations. However, I'm not gonna concern to that because I've talked about class A a lot. Of course, there are still some issues to be discussed, but I still want to focus on finishing the mouse and doing modification afterwards. So maybe I'm gonna do an additional video where I show you how to solve this problem. As you can see, there are a lot of things to be shown today, and I'm not gonna go into detail too much because I've showed some things already, so you have to watch my older videos. And there's also one prerequisite: if you want to exercise this, of course you have to watch the other videos to get this kind of state, because this is the state, I mean replace phase, law extension, which I have shown within my last video, which I'm now going to link to the upper right. So have a look at my last video and the video before about how X-form is going to be used therefore to really be able to catch up this tutorial. Now I think it's time to start, and therefore I am going to really delete everything which you can see here, which I'm going to do today. And what we don't need is this body, and I'm also going to hide the display here, the analysis display. I need my datum coordinate system, and I need my trim sheet upon here, and my images, of course. So I'm going to show my images. And one thing I'd recommend you to do if you are working with images, this one is really disturbing. Position them in the center, because they are right now overlapping my geometry and it's really hard to identify things. As you can see, it's pretty simple to see from the inside, but not from the outside. So I recommend you to put them on this plane. I was, to be honest, too lazy to do that, so I left it as it was. What do we need now? We need an offset of this one, because you can see this is my top and there is a kind of gap in here. And I'm not going to trim this curve. I'm really going to create an intersection between top and this one because of aesthetic reasons. So therefore, I'm going to use my offset surface command, which is here. And I'm going to relate it to a body, to this one, and just reverse direction. You can see I have already a proper value of 2.25 millimeters here. And if you compare, the outline is nearly matching the outline of this gap in here, so that's perfect. And I'm also going to extend this by use of extend sheet, and I'm going to use sheet edges selection rule because it's one relation to the overall sheet body. Offset 5 is okay, and now we're able to trim. If I do not extend, just have a look, there is some, well, it's not intersecting overall, so it makes sense to extend. Even if it is intersecting, it still makes sense to do that, because if you are modifying your part, there might be a problem if you have a gap between, so it might make sense to do that. So let's create our intersection curve with this one. I'm going to create my older body first and then my newer body, and here is a beautiful curve. Beautiful, that's the question, because if you are showing knots, you can see there are a lot of knots inside. And I could use advanced curve fit now, but it don't make sense because I really have to have a look at the problem within the law extension, which is causing this number of knots. However, poles, etc., the continuity is fine. I'm going to leave it as it is for this tutorial. Here's my intersection curve, and I guess I don't need this top now, so I'm going to hide it. What we need is this one and the intersection curve and some kind of splines, but therefore I'm going to show my images again. Here you can see there's a straight area. That's what I'm going to concern first. But therefore I need a coordinate system related to this one. It's selected ceases here, so there is an associativity. And I'm going to draw a line next. Curved line, and it's starting at this point. And I'm going to use normal to my plane here. And the value is 40. In this case, minus 40, which is fine. Like this. It's just approximately, but I'm not going to go into detail that much. This is one of my prerequisites we have, and I'm going to hide this one. It's not required, therefore. And now I'm able to draw some curves. I'm going to use Studio Spline, therefore. And the method I'm using now, I have already shown you within the Vehicle Design Class A Surface Tutorials, which I'm now going to link on the upper right, because it's somehow a prerequisite. I'm going to start here, and I'm going to end here. This is my spline. But of course we need some, well, kind of tangency here. So I'm going to open constraint, select my first point, which is here, and specify a tangent like this. It just needs to be reversed, and you can see it's tangent now to, well, however, this y-axis. Here you can see degrees 5, which is not necessary because we got 1 point and we got 2 poles. It's 3, so a degree of 2. Must be satisfying. If you enable poles, you can see poles and knots. There are no knots. Target is always to have 1 segment instead of several segments, of course. And now let's do some fine tuning. I'm going to hide my law extension, and you can see we have to do some fine tuning. And we could do fine tuning law extension as well. I'm going to show you why, because if you specify constraint here, maybe I should have just created another relation to my law extension here. That's what you can do. You can specify tangent and use this edge, therefore, and just reverse it. And now I can hide my law extension as well. And of course, we need some modification. Here you can see a knot, because we have 2 poles here, meaning 4 minus 2 is 2 segments. If I increase, we got 1 segment. And what I'm going to do now is I'm going to move my poles like this and this one by just right-clicking one of my start or end positions, specify constraint, and now you can easily move your poles like this. Pretty simple to do. But I'm also going to check my curves. I'm going to check my comps here because I want to make sure this is still smooth enough. And you can also increase here like this. And well, you shouldn't work on the angle because we now have a relation to the law extension. And if you remember, we have created specific angles within law extension. And if you need some fine tuning, which is here seems to be fine, but if you need some fine tuning of angles, you have to do it within the law extension. It don't have to be perfect. You can see there's still a little bit of a gap. So fine tuning can be done afterwards or within the law extension command. My first curve has been drawn and I have applied the command, as you can see, and I'm gonna concern the next situation here, which is much more simpler to do because I have 1 point here which is tangent, and I have another point here which is, well, just G0, so I can leave it as it is. And if you compare it to the image, it's nearly perfect. And also here I'm gonna specify a constraint like this, and we have a wonderful match. But degree is too much, I'm going to reduce it. And also here, well, if you have a degree of 2, I think comps is not really necessary to do. There can't be an inflection, but we also don't have knots and poles. I think poles is clear now, so I'm also going to apply this one. The next scenario is a little bit more complex. I think I have to do some modifications here, yes. So I'm going to finish this command by use of cancel and show this one again. What we need a curve here in that area. And what I'm going to do now, I am going to trim my law extension. I don't have a trim area here, and you could define a new plane like this. But this is something I do not recommend you to do because it's hard to read from the part navigator. So I recommend you to create an external plane always if you do trimming operations. So simple to do. And I just have to restart my trim, select my face, and I'm gonna trim it like this. So now I can create a curve from here to here, but there's still something we need. We need another trim. Well, it's not a trim, obviously. It's not trim body, I mean. It's a trim sheet, what I need. And this is my sheet body. It's a relation to a body. And my boundary object is also this curve. And it's a feature curve. It's the overall curve. And my region to be kept is the lower region here. Why do I need that? Because I need this endpoint for my endpoint of my curve. I could have used a spline now, but it is very hard to define a spline which poles are, well, some kind of just scaled. You can see there is a smaller area here for a spline, and I really want a scaled copy of this one. And it is possible by use of the bridge curve, which I think is really, really cool. I'm just going to reset this. This is my first section, and this is my second section here. Well, there's something I forgot, I guess. I'm going to just extrude this curve, and of course into Y, because I need this edge here. And I'm going to restart my bridge curve again. I need this one and this one. So what you got to do here is just reverse once. And if I compare my splines now, you can see it seems to be fine. I think it might be satisfying somehow, but I really want to make sure that the poles are scaled proper. So I could run analysis now and show poles, however. It doesn't show me the poles anyway. Here it is, show poles. Yeah, but it's not parallel. So what you can do in here is using template curve, which I love doing. It's this one, and now you can see this one is a little bit shorter, but the distances between my poles, I mean the distance of my polylines, are proportional now. And this is very important for smoothness of my surface afterwards. So let's have a look at my result again. I'm going to show knots and I'm going to show comps. And of course, yeah, the comp looks different, but this is just because of the scale, which is different. If you want a unique scale, there's something you can do. Start your curve analysis and select both curves, and now you have a unique scale. And you can see both are very, very similar. So, but I'm gonna cancel that, it's not required. And I'm also gonna hide my knots and poles. There are no knots, obviously. And, well, think about the next steps. What do we need? Not that much, we can directly start creating our surfaces, I guess, but there's something I missed. It's a connection here. There's something we have to consider. We now have unique splines. I mean, the mathematic function is equal, the function itself, but not the parameters of the function. And I want my line to be at, well, somehow 50% of this curve to 50% of this curve to really have a smooth surface. And what can we do? We can create points on curves. And I'm just going to reset this. It's point on curve. There is an option here called location. It's U parameter. This is a relation to our spline mathematics. And I'm going to select my feature curve and use 50%. And I'm going to apply this. And I'm also going to create a point here at 50% of this curve. We need another extrude. And of course we need a curve between those. And therefore I am going to create another spline, a direct connection by use of the studio spline. And now I have a line, but this line is not tangent to this surface. And I have to make sure to have a tangent line. So what can we do? You can define a constraint in here for the first point, which is this one, I guess. And the other one also has to be tangent, so I'm also going to do it here. And we now got 2 poles here and 2 poles here, meaning it's 4 poles and degree has to be 3. And now we're able to create our first surface. But I'm also going to extrude this one. And you can see it's not required to trim the curves, and I recommend you to leave it as it is. We have a perfect relation to one feature and it works pretty fine. What we also need, of course, is our continuity control to my first primary, which is tangent. And I guess to my first cross curve, which is also tangent, like this. And I'm going to, I guess I'm not finished yet, because I really have to control my knots, etc. You can see we have a lot of knots in there. And of course we can do some auto fit tuning, however, but there's something I'd like to show you. We got the output surface option here, and there it says construction is normal. If you set this to simple, the surface will be simplified. What does it mean? We don't have any knots in here, and there is no requirement of using settings. And if you have a closer look at the poles, I'm just gonna undo this to normal. You can see it's less poles being used. Pretty cool. It's just one thing. It's not working every time. It's not working with this kind of surface, which you will see later, but it works really fine with 4-sided surfaces. I'm gonna apply this and create my next one. And also here, I have used the simple option and show knots. There is one knot, as you can see. I guess it's caused because of this area. I'm first of all going to leave it as it is. So I don't want to worry too much about that, and I'm going to hit OK. And let's check now. I think it's, yeah, it's also because of the law extension. I don't think it makes sense to do any fine tuning here. We could have deleted G1, etc. And you can see there is still a knot. It's because of the law extension. What else can we do? You could search for a better solution while using normal instead and defining via autofit. And you can now see there is no alert displayed. I'm not absolutely sure, because when modifying through curve mesh, we don't get a display of an alert. I'm gonna hit OK. There is no alert. So here you can see simple is not the best choice in that case. What does simplify do? It simplifies also this area here. That's the advantage of using simplify. So if I use simple, in that case, it doesn't really help us. So I'm gonna leave it at normal. Well, there was just a little movement in here. It just moves the poles around. You can see it better in that case. If I open this one again, and can I unset this? Yes, it's just moving the poles a little bit to get more equal distances between the poles. If you use simple, you can see it's more equal. I'm gonna cancel this. So we now got class A here and class A there. I think it would be possible to create this within one step, but it's pretty hard to do because you really have to control all those 3 curves to have them somehow equal, meaning equal concerning the polynomial function, and it's not right now. Well, I'm satisfied with this, however. So, do we have a bump in here? Well, we had a bump if we do the following. If I create a through curve mesh without using this one, which I did in my first run, it looks pretty cool. It looks pretty good, but don't use this shaded view to get an impression of your aesthetics. Let's have a look at an analysis reflection. And let's use, well, let's use this one and just rotate a little bit to this side. Well, it looks pretty good actually. My first one wasn't that good, but let's have a look at face curvature as well. In my first run, I haven't thought about this curve and I received some problems. What we can do as well is analyzing slope, of course. There is a slope analysis available. I guess it's below here. Face shape, it's called slope. I guess it's better to use this one as well. I haven't checked the knots. We have a knot in here. And, well, just use normal. Also here, and autofit. And autofit as well. And, well, there's G0 exceeding. This is not good. However, let's have a look at the curves. Let's add another curve. You can see it's more following this curve. But we still have a tolerance issue here. Well, you can try doing it within one step, but I've decided to do it within 2 steps instead. And let's now think about the last surface to close this lower area of the part. And how do we do that? It's a triangular shape. We can select a point, an endpoint, as our first section. And now select a section, middle mouse button twice, and another section, and another section. That's what we can do, and the last one is curvature constant. And we have an issue here. There's something I guess I have to redefine. I can finish this, but it's not perfect. There's something we can do within here. I forgot. It has to be curvature consistent. Maybe you have recognized I forgot. It's just tangent. That's a problem. The surface cannot be curvature consistent if the input curve is just tangent. So I have to define tangency. How to do that? It's not possible right now because I have to increase the degree. So it's a right click, G2 instead. I'm going to specify constraint here as well. And here is my surface, no alert, etc. I could have used analysis now, so there is a possibility to do that. And there's something I missed. I told you before I started doing these surfaces, there is a possibility of using this one as an input. And you can try that, of course. So this is my second primary here. So I can create a relation which is tangent to this one. And you can see there's no alert, but I also will check the knots. We don't have knots, poles are fine. So you can do that, and you might find out there's a little bit of a difference between using this one and not. We have it here, we have done so much effort to create it, so why not using it? Something I forgot to check is also the knots in here, and if you remember the first situation, which I've deleted, so my finished first version of my mouse, you did also see some knots in here. Let's now have a look at our reflection, but therefore I'm going to mirror this. So I'm going to move it to my latest timestamp, and I'm just going to edit those. Let's have a look at the shaded display without edges. I think this area could need some redefinement, but I don't trust the information, so I'm going to use reflection instead. Tangent face is not working here because the faces are not sewn yet. It looks smooth, and it looks smoother when the tool is not displayed. You can see it looks pretty smooth. Also this area. Well, here I don't like this display. It's not perfect. We need some redefinement. And let's have a look at the most important analysis, which I guess is here, slope analysis. I don't like the display here. Well, the problem we have right now is the face normals. So I really have to sew it now to get a proper information. And the face normal of this surface will be inherited to the rest, of course. And if I enable my display now analysis, slope, you can see we get a proper display. So it really is the face normals. Another possibility of reversing face normals is just to reverse the direction of your input curves within your surface command. There's something I don't like. I don't like this transition. And maybe you don't as well. So what you can do now is delete this tangency. I guess it's gonna work without. And it will look much smoother, as you can see. I'm satisfied, and I'm absolutely sure there is not much of a fine-tuning required to get a better result. But however, I don't want to exceed this video too much. I guess it's somewhere around 30 minutes now. I hope you liked this tutorial, and I'm absolutely sure you have learned something, and you did see that even my construction is not perfect. So I do not always consider everything. I need to do some repairing, etc. But however, it was not that hard for me to find the mistakes and the problem areas. I guess that makes a difference between an experienced freeform user and somebody who's starting creating freeform shapes. If you like my videos, give it a like. It's 30 minutes. I hope you're still there. Give it a like if you like it. And subscribe my channel if you haven't yet. And I'm still gonna continue uploading videos also concerning freeform, also concerning this magic mouse, some modification I'm gonna do. Have a nice day. Goodbye.